Hello and welcome to Zetron's Tech Talk, answering 6 important questions about integrating mission-critical push-to-talk with emergency communication centers. My name is Randy Richmond, and I'm Zetron's Standards and Regulatory Specialist and one of Zetron's MCPTT subject matter experts. Before we dive into answers, a note about mission-critical push-to-talk. FirstNet may be first to market with mission-critical push-to-talk. They now offer their FirstNet MCPTT service, but FirstNet is not your only option. All major carriers have declared their intent to support the global MCPTT standards. The answers I provide here are applicable for connection to any carrier that supports those global MCPTT standards. So let's jump right in with our first question. Question 1. What can MCPTT do compared to land mobile radio systems? This question is relevant for emergency communication centers because today's dispatch consoles are typically designed for land mobile radio, and that's the frame of reference. This table shows a comparison between the high-level Project 25 LMR capabilities and mission-critical push-to-talk. You'll note that apart from a few nomenclature differences, MCPTT can do virtually everything that P25 can do, with the exception of a few minor, seldom-used features not shown in this table. But mission-critical push-to-talk has the advantage of being broadband, and that brings with it more capabilities. This table shows a number of areas in which MCPTT outshines Project 25 LMR. One area is voice quality. P25 being narrowband has a narrowband vocoder, and this is adequate, but it's on the low side of the quality scale. It's hard to distinguish who's speaking. MCPTT can make use of high-definition, wideband audio, which is much easier to understand, even to the ability of recognizing the talker's voice. Another area is imminent peril. It's a new, lower level of emergency, giving 3 states of urgency: normal, low or imminent peril, and high or emergency. Text messaging on P25 is limited to units, not groups, and can only do index CAN messages, while MCPTT can do both unit and group text messaging with free-form text. Another area is unit location. On Project 25 systems, this can only be sent, not received by field units. Location can typically only be displayed at the ECC and typically on solutions provided by the same manufacturer as the P25 radio that sent it. This is because of the limitations of the Project 25 location standards. Whereas with mission-critical push-to-talk, location can be sent and received by all MCPTT users. Then there are a group of 4 unique MCPTT features that I'll explain next. Question 2, what is group management and why is it useful? Those last 4 features from the last slide are what are known as mission-critical push-to-talk group management. Group management is not something found in LMR systems. It provides a series of capabilities that give dispatchers much more visibility and control over incident groups. One area is dynamic talk group creation. This allows dispatchers to create new talk groups on the fly. One use case for this is to create a custom talk group for an incident. Another area is remote talk group assignment. This allows dispatchers to remotely place field users in specific talk groups along with the above feature. This allows dispatchers to not only create new incident talk groups, but to place the first responders for that incident together in the same group so they can immediately start handing off coordination en route to the incident. And another area is talk group query. This allows dispatchers to see who are the members of a talk group and to see which talk groups a user is a member of. This is very useful in trying to track down how to communicate with a specific person. And another area is dynamic priority uplift. This allows dispatchers to elevate the priority of a specific user or specific talk groups so that in case of a cellular network congestion, even congestion from first responders on less important incidents, the higher priority users or groups can always get to the top of the queue or even preempt existing traffic if need be. Question 3. Can I upgrade my existing LMR dispatch console to do mission-critical push-to-talk? Maybe. It depends on your console manufacturer and their MCPTT plans. There is the possibility that existing consoles capable of interfacing to the Project 25 console subsystem interface, otherwise known as the CSSI, that they may be able to connect to a carrier's LMR MCPTT interworking function, known as the IWF. In those cases, the console may be able to communicate with MCPTT users whose talk groups are linked to LMR, but the console's capabilities will only be that of Project 25 and won't be able to do the special MCPTT-only capabilities. Console vendors with a true commitment to MCPTT will provide ways to upgrade existing late-model LMR consoles with direct MCPTT interfaces capable of supporting all of the carrier's MCPTT capabilities and capable of talking to all your agency's MCPTT users, not just those that are linked to LMR. Question 4. Can an MCPTT console also do land mobile radio to mission-critical push-to-talk integration? LMR to MCPTT integration allows users on your land mobile radio system to communicate with designated talk groups among your MCPTT users. Consoles that have connectivity to both systems should be able to patch traffic between LMR and MCPTT. Some consoles might allow such patches to be permanently nailed up, but most consoles put patching under dispatcher control. The recent protest riots had incidents where protesters illegally played music over the public safety LMR system, making the LMR system unusable for public safety. In some of those cases, public safety reverted to using FirstNet or other broadband push-to-talk schemes for their communications. If those agencies' LMR systems had been permanently patched to MCPTT, it would have made both systems unusable. The advantage of dispatcher-controlled patching is that it allows dispatchers to decouple LMR and MCPTT systems in just such a situation. Depending on the solution, patching can bring with it issues about latency. That is, the ear-to-mouth delay, and it can greatly increase. It can bring about issues of floor control that has to do with cross-system traffic that may occasionally have undetected collisions. It can bring about issues with talker ID. The ID shown on the recipient devices may not be the ID of the originator, and it can bring about issues of features between systems. For example, emergency might not cross between LMR and MCPTT systems. Less sophisticated solutions might only be able to patch group voice between systems. Question 5. Is there an advantage to integrating mission-critical push-to-talk with my GIS and CAD systems? And the answer is yes. Most ECCs have a professional geographic information system used to map the location of incoming 911 calls. Today, most agencies are not showing the location of their first responders on those maps. It's difficult or expensive to obtain that information from LMR systems. But with MCPTT, the location is ubiquitous, and it can be delivered to your GIS, allowing ECC staff to see where both incidents and responders are in relationship to one another. Virtually all ECCs have a computer-aided dispatch system used to create and track incidents. The CAD system knows which incidents exist and which first responders are assigned to each incident. If you marry this knowledge with the MCPTT group management capabilities, CAD systems can automatically create a new incident talk group and remotely assign field users to that group. This level of automation frees up that duty from dispatchers. Question 6. What about the MCPTT vendor's dedicated mission-critical push-to-talk console? Some of the vendors that the carriers use for their mission-critical push-to-talk solutions also offer a browser-based, single-purpose, mission-critical push-to-talk only dispatch application, and these can be relatively inexpensive compared to traditional LMR dispatch consoles used in ECCs. Many of these consoles are cloud-based. Depending on the distance between their host cloud and your ECC, there can be a significant increase in the mouth-to-ear latency, sometimes on the order of multiple seconds. Compare this to the approximate quarter-second latency of consoles designed for ECCs. Compared to consoles designed for ECCs, these single-purpose consoles lack the aural, visual, and data integration with other ECC systems. They typically require their own separate speakers and microphones and don't integrate with the dispatcher's workstation audio system. They typically require their own video monitor, adding to an already crowded dispatcher workstation. They don't allow patching of the ECC's land mobile radio system to mission-critical push-to-talk. They typically don't integrate the MCPTT voice traffic with the ECC's voice recording platform. They typically don't integrate with GIS systems for mapping MCPTT users on a common multi-layer Esri map. And they typically don't integrate with CAD systems for automated talk group creation and assignment. You'll note that many of this Tech Talks answers involved integration within the ECC. The ECC is the Public Safety Communications Hub. Well, this recent pandemic has put an emphasis on being able to distribute some elements of this hub to the cloud and even to the homes of telecommunicators. The basic cross-system interfaces and the need for cross-system integration still exists. The automation expectations of broadband, such as NG911 and MCPTT, are all the more important in today's broadband world, so as to ease the information overload of ECC staff. This is why it's important to select vendors who have a commitment to open standards and interoperability. Zetron offers solutions for the entire ECC ecosystem, and we are committed to this pursuit. Hopefully you found these answers helpful. If this topic is of interest to you, I encourage you to follow Zetron's blog page, and you can see the address here on this slide for an upcoming follow-on blog answering 6 more important questions about MCPTT integration with emergency communication centers. Thank you.